Hey Chicago Urbana, what's up? How you doing? Having a good conference? All right. Okay, my name is Huyen Tue Dao, and I'm here to talk to you about dissecting the standard library. So this is actually the second part in, I guess, what is now a series, because there's 2 of them. And if you saw my first talk, you kind of may have heard that kind of like the whole idea is that, okay, I'm asking myself this question. I've been doing Kotlin for about 2.5 years now, and there's this question that I still can't quite answer is, what is idiomatic Kotlin and how do I write it? And so the first part of my talk, I kind of just, and I've been told that I went very, very fast, because I'm a fast talker and I had a shitload of shit to talk about. I went very fast through a bunch of features, and kind of like language features, showed like where they were in the standard lib, how they worked, and how you can kind of learn from them, emulate them, and kind of rip them off into your own cool thing. So I think that's actually a pretty good metaphor for kind of how like I know my Kotlin, idiomatic Kotlin journey has been, where at first you kind of look at examples, you copy it, you try to figure out, okay, what can I do with it? And then the next stage is kind of, what should I do with it? And so that's kind of what, so instead of like, basically like blasting you all like the Dolby guy in the chair and going at a million miles a second, because I'm going to do that anyway, rather than go through a million things, I kind of want to go through a few things, deep dive really hard into them, and kind of try to see what it is, what's the Kotlin DNA, what is it that makes Kotlin Kotlin, and maybe try to take some of that and put it into everyday Kotlin, and hopefully one day, someday, get closer to being idiomatic. But I think the first question, which is a good question, is what is idiomatic Kotlin, or what is idiomatic code? And if you Google, you don't get great answers. You get answers that, oh, it's native code, or it's natural code, or it's code that follows language conventions. And it's probably a good thing that those are very big answers, because obviously it depends on the language, and it depends on the language. So how about Kotlin in particular? So what does that mean for Kotlin? And I think in the last like 6 months, I've been trying to think, okay, what is idiomatic Kotlin? Is it Kotlin that kind of respects maybe like kind of the idea, the goals, and the values of kind of be like the people that write it? And kind of the reason I've been thinking about that is that I watched the keynote from KotlinConf 2018, and Andrei Bresov actually kind of talked about some of like the kind of like the goals and values behind Kotlin. And that really got me thinking, because he said some really interesting things. So he said first that the main goal of Kotlin was to make a pragmatic language. Okay, what's a pragmatic language? I don't know what idiomatic means. What does pragmatic language mean? And basically said, okay, we want to write a language that helps you get things done. And this was the part that I thought was really interesting. He said, we want you to be able to turn your thoughts into working software without, any hoops to jump through. And furthermore, I think that when we think about Kotlin, there's things that excite us, right? There's things that we want to try out. There's things that make it look really sexy and cool. And surprisingly, watching that keynote, there were certain things that I thought are really cool that Andrei was like, wow, those are great. But there are actually things that, we kind of value above these things. And some of those things I think are things that I think about when as I'm looking at some of the features I'm going to talk with you about today. And after hearing that talk and after hearing Andrei's perspective on these things, I'm trying to look at Kotlin a little bit differently. And rather than just use all the cool things and put everything everywhere, because that's really fun, is to try to kind of align myself more in the Kotlin thinking. And maybe idiomatic Kotlin isn't the best thing for your project or your day or whatever you're doing, but I think it's important to understand what it is and understand how the people who wrote it and are kind of working on it think about it, so you can make the decision, what is idiomatic Kotlin? Does it work for you? Does it doesn't work for you? So let's answer some of those questions. And the thing that really surprised me, I think, was that Andrei said that, people laud Kotlin for concision, but really what they want is readability, right? Concision is nice, having shorter code is nice, unless you have like code golfers on your team who like to write as small code as possible to the point where it isn't readable. But I thought that was really interesting. It kind of made me kind of reevaluate. Am I writing readable code, or am I just writing concise code? And something else he said, which is really interesting, is that rather than valuing expressiveness, they value reuse, right? Abstractions that you can reuse everywhere, rather than having a language that lets you do all the things, although that is very nice. Something else that was really interesting was also that one of their values is, rather than necessarily being an original language, and I interpret that as being, kind of really cool features, kind of different, unique things, is interoperability. And I think for a lot of us, I know on my team, that was kind of a big deal and kind of why we picked up Kotlin anyway, is that instead of taking this thousands and thousands of line Java code base and throwing it out and trying to write everything again in Kotlin, we had interoperability. We could kind of, adopt Kotlin bit by bit and not just kind of like have things live next to each other, but have things talk to each other in a reasonable way. And there's more things. I actually had to Google what soundness meant. It's very academic, so I'm not going to go into it. But, okay. All right, so apart from, okay, now I've learned how lambdas work. I'm going to put them everywhere. I've learned how this works. I'm going to put it everywhere. Let's actually think about what the features, how they're structured, and how they reflect these values, and how maybe we can kind of think a little bit more in the vein of like how the team that is writing it thinks. And I think one of my favorite things that I think kind of echoes these values for me is conventions. So, very broadly, conventions are this idea that you can use certain language features, certain constructs, and that the use of these things are tied to functions with very specific names, as opposed to being tied to specific types. So, example, Java has several things, has several features, has several syntax that you can use for certain class and server interfaces. So, one of my favorite examples, and something that I loved when I first came across it, is try with resources. So, if you've ever done I/O, it's a pain in the ass. And you know that you have to open streams and close streams, but sometimes when you close streams, it throws an exception again, so you kind of have to catch the thing on the close. And anyway, it's a mess, right? And what try with resources is this language construct that abstracts it away. You basically just have to create a resource, and then Java will do the work of opening it, closing it, and handling any kind of weirdness that happens at the end. And try with resources is a construct that is available to you if you're working with an auto-closable class. So it's a feature that is tied to a specific, interface. Now, kind of closer to home, maybe more typical is for each loops and iterables. So like in Java, you have this really nice succinct for loop syntax. Let me put that up a little bit so you see it. Where rather than messing around with indices or iterate, like kind of like handling iterators yourself, you have this really nice for syntax where you can specify like an iterator, like an item variable, and you can specify the collection iterable thing that you want to go through, and it does all the kind of work for you. It's very nice, and again, this is nice succinct syntax that is based on implementing the iterable interface. And these things are in Kotlin too, and I think again it's part of that interoperability story where, okay, we don't just abandon things, we want people to be able to kind of adopt Kotlin with their Java, and so we bring certain things. And I think if you read Kotlin in action, there's some really interesting discussions about kind of decisions and language design that are like, hey, we want to kind of echo or mirror behaviors and things that you do in Java to make the transition to Kotlin easier. And so, like the iterable interface and this nice for loop syntax, you have it. So, in list and set, these are both classes that implement iterable, and rather than for : you have for in. But, again, these are language constructs that are tied to interfaces. So, that's all well and good, but say, like, what if you have a class that doesn't implement these things? What are you going to do? Well, if you're in Kotlin and you want to add functionality, and for some reason you can't, make something implement an interface because maybe you don't own it, it's an external library, or for some other reason, you have Kotlin conventions coming to the rescue, and all you need is the right function name and a little bit of a keyword modifier. By the way, side note, and actually very related, is that you might kind of wonder why try with resources isn't one of those things that you get to use nicely in Kotlin. That is because Kotlin is compatible with Java 6. You can compile to Java 6 bytecode, but as I said, try with resources requires auto-closable, which wasn't introduced until Java 7. So instead of that, you have this kind of use stdlib method, but kind of an example again about when something is tied to an interface or a class, you might not always be able to get it. So which is why I think it's really interesting to kind of examine conventions and how they're trying to address these problems and how kind of Kotlin has a different perspective on these certain things in Java. So operator overloading. So I started out as a C++ person, but I've been doing Java for the last years, and I've really missed operator overloading. Also known as operator ad hoc polymorphism. I did only just learn that this week. But basically, it's the idea that, okay, there are these symbols, right, these operators in the language. And operator overloading allows you, as a developer, to assign custom logic to these symbols, to these operators. And it's really just syntactic sugar. But again, kind of like these ideas of making things more readable, more intuitive, kind of, again, falls along the line of readability, right? Also concision, because generally they, one symbol tends to be shorter than a full function name. But it's kind of this idea of, yes, we want to make code more readable, more intuitive. And what I think is really, really cool about operator overloading is that, okay, how many people love extension functions in Kotlin? Like a lot of people? Right. I do too. And I think what's really cool about operator overloading is that it's kind of, if you will, kind of part of that extension function idea, an extension of extension functions. And the idea is that, okay, you know, it's hard to add functionality when you don't own a class in Java, right? You might have to write utilities in a public static class and have like less than ideal, you know, function calls, or you just have to own the class and be able to kind of extend it or, you know, subclass it. And that's not always great. Kotlin tries to fix this by kind of letting you basically like have your cake and eat it too, by being able to add functionality and, you know, not have to own the class, not have to subclass it, but also still getting some nice, you know, intuitive, cleaner syntax. And I think operator overloading kind of plays into that and is kind of part of that idea and that system. And there's kind of interesting things about interop as well. So the closest thing that we even had to operator overloading in Java is using the plus operator to concatenate strings. It's been like a sad number of years for me in Java, but now it's a little bit different. So in my kind of first part of this talk, I talked at length about kind of my first love with Kotlin, which was the collections API. And it's this kind of just, you know, these kind of, again, extension functions, additional behaviors that are not, you know, kind of things that have been stuck into like the base classes but have been added on top. And what you get is these really nice, you know, chainable operators that are really fluent, and you can do very complex things. And even though, sorry, they're really complex, you can read through the code in a, you know, relatively natural language kind of way and understand what it is. It's more readable. And it's not just that in the Kotlin standard library we have, you know, this really great collections API. We also have operators, overloaded operators. So happy about that. So, continuing from last week's show, where we are on a spaceship of voyage and discovery, boldly going out to meet new life and new civilizations, boldly going on an intrepid ship full of scientists, adventurers, and explorers, and occasionally crazy captains that like to overact. We're going to work with some Kotlin. And say that I'm putting together a ship of, you know, these intrepid adventurers, and I want to, you know, kind of just very easily put together a list, say a mutable list of crew members. Because I have operator overloading in Kotlin, in the standard lib, rather than calling plus this person, plus that person, plus this person, I have this really nice plus equals assignment operator. It looks very familiar to, you know, just using it kind of in day-to-day primitive operations in Kotlin, and we actually have it in collections. And what's really neat is if I click through, you can see that it's an extension function. It's not something that's actually in the collections class, but it's an extension function. And this is kind of basically what operator overloading looks like in Kotlin. So there's a couple of things that we should take note of. Number one, that it's an extension function. So again, this idea of adding functionality, adding utility, and at the same time, not having to, you know, own the class, and also just not adding extra baggage. I think you know, if you've watched different talks by Andre, he said that, you know, they want to make it so that you can keep your abstractions clean, but not have to kind of struggle to add utility. And I think that's kind of, you can see that here in extension functions and by extension, operator overloading. And so there's also this little operator keyword, which we'll take a look at later. So I have here my list. I've added a couple of crew members, a commander, a doctor, and if I go ahead and run this, I can see that I have an error in my code somewhere. If I go back and run, so what this hopefully is doing is adding members to my crew list. Oh, and here they are. Jason Nesmith, my captain, and my Dr. Alexander Dane. So as you can see here, it works. We've added a couple of members to this mutable list. Cool, operator overloading works in collections API. That's great. What if I wanted to add that really awesome functionality and notation like to my own classes? Well, we can do this. So say, instead of just a crew, I had a ship. All right, so the idea is that, okay, I have this collection. It's just a list of my crew members. Say that I had other information that I wanted to encapsulate about my ship, maybe the name, maybe the type of class it is, and the crew as well. But I still want to have that really nice notation where I can kind of go through, iterate through my crew members and, you know, assign them things or, you know, send them off to their, you know, inevitable deaths off screen somewhere. So I have this ship class, and it has the name, the vessel class, and the list and the crew. So what if I wanted to say, do something like I did back here with the collections? with the collections where I can actually iterate through each one using this really nice for loop syntax. Well, there's a couple things I could do. Number one, I could implement the iterable interface, which I mentioned is kind of like one of the keys that opens the door to that really lovely for loop syntax. But, and oh my gosh, in light mode, those tooltips are unreadable, I apologize. Instead, what we can do is instead of using iterable, we can use iteration by convention. So rather than implementing this iterable interface, all I need to do really is to go down here. Now, what's really cool is that, again, because operator overloading is kind of related to extension functions, you can implement operator overloads as either member functions or as extension functions. So I'm going to go ahead and be daring and do this iterator function as a extension function. So keyword operator, fun, because it needs to be a function. And because it's an extension function, I'm going to type in my receiver class. And what's really, really cool is that, you can see, the IDE will help you with this. So operator overloading is kind of this really powerful tool, right? The idea that you can take a kind of really basic symbol in language and just put all kinds of custom stuff in it. Now, okay, cliche, great power, great responsibility, but it's true. And there was a very purpose-like language design decision to kind of narrow the scope of operator overloading. So there's a very small list of what are functions. So these functions are, the names of these functions are basically what Kotlin will allow you to map symbols in the language to a certain custom behavior. So you can see things like iterator, minus a sign, plus a sign. And what's really great is that the IDE kind of helps you with this. This is a code completion that just pops up. And you can see that it includes both the name of that function, that convention, that naming convention that you need to kind of add in your custom behavior, and also the actual operators that that kind of can map to. So I actually want to do iterator, and because I'm lazy, I'm just going to delegate to the crew's iterator. So I didn't do anything special. I didn't like implement an interface. I didn't change the class or subclass it. I just added an extension function. But what that buys me, if I go back here and I change this to, okay, so now rather than just a simple list, I have a slightly more complex class that has a list of crew in it, but some other information. And say I wanted to go through and iterate through my crew list, but directly in the ship rather than on that list property inside of it, I can do something like this. And let's just say, let's print us the whole member, just so we can get lots of nice logging. Okay, that looks good. Run. And cat go. And here we go. So as you can see here, rather than iterating through a list, I've had this class that I wrote all by myself, and I added the ability to call this really nice syntax. And that was all done not with interfaces, not with the subclassing, but with conventions, with this extension function. So let's add a couple more things to make it interesting. Let's see. Plus a sign. All right, so again, there's a very small kind of group of things that you can operator overload. Some of these are arithmetic functions. And I think, again, so like when you first do Kotlin and you see all these wonderful little things, you just want to put all of them in your code, right? And then you kind of wake up and you look at your code a year later like, oh my God, what the hell did I do? And I think operator overloading is one of those things that you have to be careful with. And like part of it is, and I've seen, again, like if you watch talks by like Andre or other members of the team, they are very explicit in saying, we want to give you this, customizable behaviors, customizable operators are really powerful, but they should not be abused. And it's kind of when the kind of scale tips from being really concise and readable to, oh my God, what is this code doing? And so a question you have to ask yourself, and I think this is kind of one of those things that plays into not just good code, but idiomatic Kotlin is, what does this mean for my code, right? So I have a ship. It has a list of crew, which I want to iterate through. And people will hop off the ship, hop on the ship, maybe they die, maybe they transfer in. And so there's this idea that, okay, I'm adding and subtracting from this collection of people. There's some extra data in there, but I'm going to say that it's a collection of people. So that's kind of my reasoning for adding this plus a sign and minus a sign. An example that, that might not be so good is, and I think this came from actually a talk that Andre gave, is like, okay, take the slash operator, right? It's usually division. Please, please, please don't overload that to be like a slash operator on a path, right? So there's this idea that try to, when you're doing these things, it's really great and shiny and awesome, but kind of know what you're doing and make sure that you're not kind of shooting the moon and getting into kind of unreadable code. So yes, so here I have plus a sign and minus a sign, and again, its naming conventions. So I have this little operator modifier keyword, and then I have a very specific function name, and kind of also requirements for these mappings is to some extent, it depends on which one, parameter and return type. So if you think about, let's think about what I'm trying to do. I want to add this plus equals operator that is kind of mimicking what I did before with the collections list, right? So what that did was, okay, so I had my list, and by doing plus equals, I'm just adding an element to it, right? The reference is the same. That's the same instance. It's just there's an extra element in there. So I want, when I implement plus assign or when I overload that operator, I want to keep that same idea, right? We want to kind of keep to a standard. I mean, I guess you can do whatever you want. Sky's the limit. But again, we want to kind of endeavor towards idiomatic and understandable code that doesn't make your teammates hate you. We want to try to make it reasonable, make our abstractions kind of make sense, right? So with plus assign, here, what I want is, okay, I'm just going to mutate the data inside. And what's interesting is that you might kind of wonder what this operator modifier is for, right? Because I told you that really the compiler is looking for a specific function name. Well, the operator kind of enforces some certain things. So again, because plus assign is usually used to kind of mutate, like, say for a collection, it's mutating the collection, but the reference stays the same. Say I go ahead and return like a value here. The operator is going to complain because it says, hey, if you want this to be an operator, if you want the compiler to actually map this function to this symbol, it needs to not have a return type. It needs a return unit, rather. And that makes sense, right? And especially in Kotlin, very specifically, assignments are not expressions. So, hey, if you want it to be an actual like assignment operator, it can only return unit. Another thing is that, you know, if you think about plus assign, it's basically a binary operation, right? It's got two things, more or less. So if I try to add in an extra parameter here, operator complains like, hey, you know, it's actually a single parameter. It's operating two things, but it needs a single parameter. I guess it's just one thing, a single assignment combo. But anyway, so here's my implementation. I'm accessing that kind of internal backing field mutable list and adding a crew member to it. And kind of the reverse is happening with minus assign. So if I go back to my main function, all right, I have my ship. All right, I have a couple people on it, but that's not quite enough. We got a captain and a doctor. We might need it for a few more people. So let's go ahead and add, let's see, who else? Crew member, wait, ship. Let's add in that, that awesome Lieutenant Tony Madison, and we'll also add in crew member 8, nameless crew member that will probably get eaten on the next away mission. And let's kind of see what happens now that we've implemented our plus and minus assign. Let's see what we get when we actually go through our ship. And hey, plus assign works. We've actually overloaded the operator to, again, kind of mimic this behavior of adding elements into our ship, which is kind of like a collection. Awesome. So something interesting, if you kind of read documentation about operator overloading, they say, please don't implement both plus and plus assign at the same time. All right, ask yourself, well, why can't I do both? Why can't I have all the things? So, and this is, again, kind of back to that concept of, you know, readable code, being able to, you know, provide power and customization, but also trying to keep things coherent, keeping abstractions clean, and also just being conscious of what you're doing. Yeah, all the things are great, but there's actually good reasons why you don't want to do all the things. So what I'm going to do is I'm actually going to show you what happens, and it's kind of interesting. And again, this is one of those things where as you kind of learn anything more, you kind of start, when you start kind of like playing around, you kind of wonder, why doesn't this do the thing I want to do? And there's some interesting things to learn from that and glean from that. So if you think about when you do plus on a list, and I'm going to leave that for now. You know, usually when you kind of use just the plus operator on a couple of lists, so say I just have like a very simple list of members, and then I just do plus list of crew member, and the compiler is going to complain. So how is this different than plus equals? So I've got two immutable lists, right? And so they can't be changed. But I can add them together, and what comes out is a new object that is kind of the aggregation of the two. And so keeping that in mind, as I'm going back and trying to implement this plus operator, because I don't care what you say documentation, I'm going to have my plus operator and, you know, and my plus assign. So how about instead here, so usually what happens is a new instance returns, so we're going to return a ship. And rather than kind of just mutating the inside the internal data, we're going to return a new ship, has the same name, has the same vessel class, And it has the through plus 1. Okay, cool. Okay, so what's really interesting here is that I have plus. I don't have plus assign. And so, if I have something like this, you'll notice that it actually isn't erroring. And that's because the compiler is trying to be considerate. And what happens is when you implement something, and when you implement plus rather, and either the compiler sees like a plus assignment operator, it tries to help you out. It tries to be a good friend, and rather than just not compiling on you, it basically tries to implement plus equals with the plus operator that it has. And basically what it does is it turns it into this. So rather than, it actually turns it into more or less this. And what this is instead is, okay, so rather than changing the data inside my ship, taking the ship, calling my plus operator, which, remember, creates a whole new ship, and then assigning it to that original reference. So that original ship is gone. So the actual meaning, the actual kind of result of the code is different. And, looking at this, it compiles, you might not think no big deal, but that's kind of why they say don't implement both. And there are certain situations where this might not work. So if I go back to actually my original file, and I bring these back, what happens is, okay, so I have plus, the compiler's trying to be really nice to me and turn that into a, basically equals plus rather than a plus equals. But now I've got an error because that plus equals is now kind of assigning that original, kind of reassigning that original reference. If it's a val, then the compiler really doesn't like that because now that kind of like the meaning of that has changed, the semantics of it's changed, so now it's an error. And of course I could fix it by making this a var, but now, just the whole building's burning down, we gotta, like this, everything's gone to shit. So, again, this is just a really interesting example of, the power of certain things in the language and kind of the power of certain things the compiler can do for you and why you have to be conscientious. And what I think this is really interesting, though, is that, I think one thing that happened in Kotlin, especially with like the null safety, I know for me, that made me really think, oh my gosh, do I really want this to be null or do I want it to be non-null? Because we never had to think about that in Java before, right? Everything was the same thing. And now in Kotlin, you actually have to think about, at least you should think about, okay, if I'm making this value nullable, what does that mean? What does a null value mean here? And similarly, using this operator overloading, you actually have to really think, okay, is my class, an immutable kind of object where it kind of makes sense to, have a new instance of it every time? Or is it more kind of like a stateful thing where I kind of want to change things on it? And, it's weird because, yeah, again, getting lost in all the cool syntax, but to order, and I think this is kind of where my thinking is and where I'm trying to get to more kind of idiomatic Kotlin is, okay, these decisions, these kind of design decisions, these little kind of, do I use this or do I use that, should be kind of, you should be thinking about the larger picture, you should be thinking what things mean. And I kind of like that. It kind of sucks sometimes if I can't figure out what my code can compile, but it's again kind of moving towards readable code, reusable code, but also making sure that our abstractions are clean and kind of mean what we want them to mean, like that our thoughts are as accurately as possible transmitted into the software. So I'm going to go back and get rid of that plus, and we're going to go back to plus assign. All right. So that's operator overloading. What's really interesting is that, again, interoperability is a big part of the story here. And, as we're kind of, I don't know about y'all, but I know on our team, our code base is just too big to kind of, move to Kotlin wholesale. Just because we've got other things to do, we've got features to ship. Also, like, we kind of care about not blasting away, like, our entire Git history. So, being able to kind of, again, have that interoperability between Java and Kotlin to Java is really important. So, here we go. Okay, so, something that's really interesting is that even, if you go ahead and you start leveraging these operator overloadings responsibly, of course, is that, you don't have to abandon your Java code. Your Java code can still take advantage of, some of the new Kotlin, logic that you write. And something that, happens with us at work is that, okay, we have some Java code, we have some Kotlin code, and there's like an underlying, coherent business logic. And sometimes we might add a new Kotlin code, but then kind of some Java code is left behind because maybe there's a utility function which works in two places, but one gets updated and one doesn't. And so I think part of handling that and moving forward to hopefully 100% Kotlin one day is to understand that there is some interoperability built in. So here's a Java file. It's using these two classes that I wrote in Kotlin, ship and crew member. And even though I can't use the operator overloading, I can still use some of the, oops. So if I actually implemented this. So say I have this contains methods, which actually is another version of in that allows you to check whether a member is in a collections. You can also overload that. Ooh, another thing. Sorry. Side note. As you're doing all this, there's a lot of help from the IDE. If you see something like this where you have an operator and you prefer to use the function, there's actually kind of a refactor in the context section where you can kind of switch between the two. Which kind of depending on whether you kind of how you want your code to read or kind of does your preference, you can switch between the two. But anyway, if we go back to boldly go, let's see. Wait. There we go. You can actually call, if this compiled, a good strategy though for even as you're building these operator overloads is to go ahead and maybe not necessarily call it like this, where you call in the Kotlin code specifically from Java, but you can maybe take your existing Java utilities and delegate to your operator overloads, or your new fancy operator overloads. So whenever that file does get kind of Kotlinized, at least it's not being left behind, or that there's possible bugs because of inconsistencies. But again, it's all part of that story of interoperability, thinking about moving forward with the new stuff, kind of moving forward with better, awesomer, better, more encapsulated code, better syntax, but still kind of separated utilities, but still kind of making sure that we don't just leave the Java code behind, and being able to keep everyone happy, except for this, which doesn't compile. So another thing that I think is really interesting that is kind of in this vein is destructuring declarations. This is another convention thing. And maybe you've seen something like this. So the idea of destructuring declarations is that, okay, I have an object. And a lot of times when we have an object, we're trying to pull stuff out of it, right? We might not need all the properties, or generally we kind of are using each kind of property in some other thing. And what destructuring allows us to do is kind of break apart that object and creates variable declarations kind of already initialized to kind of the different values in that object. So you might see this is kind of my first exposure to this. So on the right here, up the top, is a pair. Okay, this is a pair of a pair of strings, 1 and 2. And rather than saying, okay, pair.first or val something equals pair.first, val something equals pair.second, I have this really nice destructuring syntax where I can just do val, this parentheses, and then it basically kind of lines up, okay, first goes in this variable and second goes in that variable. And you're not, kind of restricted to matching properties. You can do whatever you want. And this can be used for other things, like say you have a map where you have keys and values, rather than having something like this where you have the entry and okay, I got to do entry.key to kind of pull out values. You can use destructuring declarations to do something really nice like this. Or again, because you're not kind of obligated to use the same property names, you can give them more kind of meaningful names. And really, again, compare this to this. I mean, I know it's a small change, but again, it's just these incremental changes that make our code a little more readable, a little more intuitive. And like many other things that are cool in Kotlin, you can do these for your own classes. So we can actually add destructuring onto, say, our ship class. And say, maybe something I frequently do is pull out the name of the vessel type of the class. So what I can do is to make my object destructurable, is to do OperatorFun. Now this is actually one of the things that doesn't pop up in the code complete, because what's interesting is that the function name takes this form. So when you destructure something, right, there's an ordered kind of list of variable names that will kind of suck in property values from your object. And the order of those, the order of the values that kind of gets pushed out into initialization is determined by this function name. So you can have operator 1, we can have, component 1, we can have component 2, let me get the vessel name, and we can have operator fun, component 3, which is, let's say, for funsies, is my list of crew members. So by adding these kind of component functions, what that gives me is that here, yeah, I do have a main sleeping here. So what I can do is, sorry, where am I? Here. Something like this. So rather than, and this is, again, these are all kind of trivial examples, but here's something neat about this, right? My ship here has 3 properties, and rather than going enterprise.name, enterprise.vessel.class, I'm instantly declaring 3 variables and initializing them, and being able to kind of use them in a very interesting way. And you know, you might already be kind of you might already have destructured variables in your code, but you might not know it. What's really cool is that if you look at data classes are awesome because they generate so many things for you. And something that they generate are these kind of component methods. Now, when you're doing component methods on non-data classes, you're actually limited to 5. You can kind of see that it's a little unreasonable for you to have infinite number of components. With data classes, you're not restricted to 5. And in the one and only bytecode break that I have for you, unfortunately, today, for anyone who's seen my previous talks, I love doing bytecode breaks. Unfortunately, I only have one, but it's to show you this cool thing. And again, this is a data class. And as you can see down here, as part of kind of like the all-inclusive package that data classes are, you also get these kind of component functions. And for each property in that data class, in order, these component classes or component functions rather are declared. And you can go ahead and structure data classes to your heart's content. But I think that's just kind of another, again, a really interesting feature that you get just from this idea of conventions, right? Implementing the right function name and getting kind of like this extra interesting syntax out of it. So I have one more thing to talk to you all about today, and that is Infix. And Infix is honestly kind of one of my favorite little cute things in Kotlin. So as I mentioned before, the Kotlin team has very purposely kept operator overloading constricted, and you can kind of see why it kind of get out of hand really fast. Even if you're trying to be responsible and only keep plus and plus assigned to kind of very standard collection behavior, things can go out of hand depending on your use case and the particular code that you're running. So an alternative, in my opinion, is Infix. Now this is kind of one of my favorite things. So when I first started doing Kotlin, I remember seeing code like this, and I was like, oh, that's really neat. What's that to operator? And I remember very distinctly Googling Kotlin keyword to, which is kind of hard because to is a preposition, so Google just, obviously returns everything. But I couldn't find anything about it. I was like, what is this operator? And what's really neat is to is not an operator, it's a function. And what allows you to have this, function call without a dot, without a parentheses, is this infix notation. So this is not exactly a convention. It's more just like a very specific type of function call, notation that you can use. If you have a function, you mark it as infix, and you kind of meet certain criteria. So those criteria are that the function is either a member function or extension function. It has a single parameter, and that single parameter can't be a var arg, and it can't have default value. It can have a default value just because it's then, of course, it would violate the kind of single parameter idea. And also, you need the infix notation. And what that gets you is some interesting stuff. So let's go ahead, and I'm going to go back to my ship, but actually let me take a look at my crew member. So I implemented plus assign and minus assign on my ship, and I'm like plus equaling and minus equaling members onto my ship, and that's fine. I could see someone argue, but it's not really collection. Do you really think that that's standard behavior? And I could say, okay, maybe not. What if instead of using plus equals minus equals syntax, I instead used kind of like an infix function to kind of still get kind of some neat, kind of sexy syntax, but maybe kind of more explicit and more kind of more explicit to what I'm doing. So let's try doing some infix on this. So if I do something like this. So instead of, having plus equals and minus equals on my ship, say I have 2 functions in my crew member. A crew member might be assigned to a ship, they might transfer away, and that kind of equates, as the kind of implementation of these functions show, that you're kind of being removed from a ship or being added to a ship. And now, so they have one parameter, they're member functions in this case, and I've got kind of marking them with infix. So if I go back here, actually let me go to here and say I do something like infix. Okay. All right, so say I do something like this. All right, so here are my two infix functions that I created. All right, I know this is a trivial example, and I know like we could definitely argue about which makes more sense. Is this overkill? Is this kind of just syntactic sugar because you have a sweet tooth for it? But I mean, let's compare them, right? So on the bottom, I'm using my plus assign and minus assign operators, and on the top, I'm actually using my infix functions. And as you can see, kind of there's a little bit of, I think, some merit to looking at this because, you know, I think that the top actually kind of reads a little more, right? It's much more explicit. We don't get the kind of nice, cute, built-in arithmetic operators, but at the same time, the top could arguably be more clear. It could be argued to be more clear, and it still, you know, maybe lacks some of the visual noise of, you know, doing a traditional parentheses. And I know this is all kind of like, it feels like all kind of nits, all little like mosquito bites in terms of like your code noise or whatever, but it's something that's there and something that can actually improve the readability of code. And I think we actually had this, maybe we had this at work. Like we had like, someone was writing code that was really long and interesting. There was a lot of different stuff going on. There was like state transition and stuff, but this person who's in the back over there actually wrote an infix function that, you know, the end result of it was this really great infix function that very kind of plainly and in a very clear way stated, okay, the result is this, but with this. And I wish I could show you the code, but I can't. But there are situations where just a little bit of this sugar, just a little bit of this more kind of fluent, natural languagey syntax might make the difference, might make your code a little bit readable. And again, you can kind of compare for yourself what makes more sense here, what do you like more, and that's not actually a question maybe that we can answer, but it's something to think about, and that we do have different tools to kind of work with and handle. I'm not going to actually do a bytecode break, but yeah, like I think this is just kind of interesting. So like, you know, it is fun to kind of go through at hyperspeed and look at all the cool Kotlin things and see what can I do, like what does this do, what does that do, how can I bend Kotlin to my will and make it do kind of ridiculous things. But at the same time, the way that these features are written, the way that you access them is kind of had a perspective behind it. And maybe some of that perspective is informed by kind of limitations of the language, things that you should do, shouldn't do. And, you know, I think part of part of both understanding what idiomatic Kotlin is, I still don't, still working on it, but getting there and deciding, do I want to write something idiomatic? Do I need to break idioms for now? Part of that process is understanding not just what you can do, but how and why, and kind of slowly, you know, getting there with your code. And maybe you will look back at code that you wrote a year ago and not say, oh my gosh, what did I do? Which actually happened like last week, like a couple weeks ago at work. Someone was looking at some code that I wrote when I first started writing Kotlin. I was like, oh my gosh, don't look, just burn it with fire, just start over again. But that's just kind of a natural part of the process. And I think, you know, it's really worth it trying to kind of see like, what is Kotlin? What is the philosophy behind it? What were their goals? And how can those goals shape and educate how you write Kotlin? And that's what I've got for you today. Thank you very, very much. And have a great Chicago Rebuttal.